when you run a SAS program, you can get two forms of output. Listing output means that you get a text file, so the printed output looks much like the print that we see here in the program. The other option for output is HTML output, which we get some nice formatted tables, and it incorporates graphics if our procedure has graphics available. Okay. In virtual SAS, I have the information for the HTML output in this handout. Also, if you're in virtual SAS, if you're doing listing output, you still want to close the HTML and you want to close the ODS graphics. If you are using a standalone installation of SAS in your department or in your office, you don't have to close close HTML and turn the graphics off. It's just a good idea too, because it does accumulate files on your in the what SAS refers to as your work folder. Okay, so if you turn them off, that helps keep your computer clear of some extraneous files. Okay, so ODS listing just means it enables a text output. All right, anything up here at the top of the program to this line that says data, anything from here to here are actually options. You don't have to have any of those to get a program to run. So these are things that make either the format of the output the way we want it, or navigate the log windows and the output windows so that things don't accumulate there. Okay. Beginning with data, that's actually where the programming essentials start for us. Okay, so uppercase SAS command, don't change how it's spelled or punctuated. Anything that's lowercase, you can change to make problem specific. All right, the first two things we see are a name of a data set called 1, and the second line on the input line, passenger. So we're creating a variable here called passenger. This is the name of a data set or a data table, and very creatively, I just named it 1. Okay? They're lowercase, so you can change this to be whatever you want. So if you're working with project 1, you could use a project and a numeral 1 for your for the name of your data set. You can use a single word here for your variable. What happens if you have multiple columns of variables? Then you need a variable name for each column of information you have. All right, data lines means then that the data for this variable, all the variables specified on the input line, which here is only 1, that the data lines then starts, this is where our data starts. So here it's passenger, has observation 128 all the way through the last 132. We have to fill in all the points in between here in this ellipsis. So in the interest of space, that's not all printed here. Okay. On these two things here, your limitations are the first character must be alphabetic, and no spaces, no special characters except for an underscore on your variable names and on your set names. Okay? So you could have in here a variable x1 is okay, but you could not have 1x. Okay, the first character of a variable name or a data set name must be alphabetic. Okay, keep it one word. So if you just, if you wanted to write, if you had for some reason 2 words, you have to put it together with no space, or you can use an underscore. Okay, after the data set, your last line of data, you can put a semicolon. You don't have to, but most often I do that. The print procedure, all this does is print the contents of the data set we name here. So this prints the contents of data set 1. So this data equals 1 tells it what do you want printed. Up here when you create data, there is no equal sign. Okay, whenever you call a data set into a procedure, you use data equals. Okay, and name the data table. If this name here, 1, doesn't match the name you gave it up here, then the procedure won't execute. Title statements, you can have up to 10 lines, and so in the lab, you can change this over to how you are recognized, or as I jokingly say, the words assigned to you at your birth. And you can change those within every program, and also you can change them within every procedure. SAS is a series of programs. Then typically, as for this class anyway, we'll have a data set created, and then we'll have a list of procedures. And so procedures then are different blocks of code. Here I have them separated by a blank line. You don't have to. It's just for ease of proofreading. I put a blank line in there. Okay? It's usually not recommended to put a blank line in your data. Okay? The data are the yellow highlighted pieces up here. All right? Proc univariate. So the procedure is called univariate. I'm operating on data set 1. I'm asking it to generate some plots in the ODS listing. And so the listing output, the plots are not particularly flashy. I'll tell you that right from the start there. All right, and then on which variable do you wish to operate on passenger? If we would have had, say, passenger, and then we would have had some other columns of information, I could list all of those variables on that VAR statement. Okay? So just given those two, first look at the output for those two procedures. All right? So on the second page of your handout, this number 1 here is SAS output page 1. All right? This is the result of the print procedure. All proc print does is say, here's the data you entered. You can have a chance to proofread it. Now, if you create a data table that's 1,000 lines long, proc print is probably not something you want to do, right? Okay, that's going to be too big. There are other ways we can check for our data for errors without printing out every observation. Okay, so if you have a really big data set, you would not use a proc print. So proc univariate. Pardon me, before I leave proc print automatically assigns this OBS, which stands for observation number. And so the data that appear here are in the order you entered them. So if you look through here and you know all of your observations are supposed to be in the hundreds, and you saw something that was 1,000, maybe you hit a digit twice in a typographical error, at a glance you can say, oh, that's the 23rd line, and go back to the program and fix it. Okay? The univariate procedure then is on the SAS output page 2. All right, and it labels it right up here at the top, the univariate procedure. Okay, which variable? Because you can list multiple variables, then here we have only one, but it tells us which one it's working on. Most of the information here then is fairly self-explanatory. It writes capital in here, but it's actually computing sample statistics, so it's really our lowercase n. Our mean here, it's giving us y bar, standard deviation of s. When we talked about skewness and kurtosis, I told you there are some measures that can be calculated for those, and so proc univariate does give a measure of skewness and kurtosis, though we didn't give any formulas for it. The sum of the observations over here, this 4179, is the sum of the y-scores. S squared is this 57.73, the variance. Okay. The uncorrected sum of squares here, the 531,061 is the sum of the squared sum of the squared y's. Coefficient of variation, this is the CV we defined, and standard error of the mean is that S sub y bar. So we get quite a bit of information just in that first table. Basic statistical measures, we have the mean, the median, and the mode. Notice here on the mode displayed is the smallest of 3 modes with a count of 4. Okay, you have to be careful what your software is giving you, whether it's SAS or something else. All right, so we know this is trimodal. It only tells us what one of those values is. We'd have to do some more work to get to what the other two values are. Variability, so then it gives us these measures of dispersion. Standard deviation and variance is repeated from up above. The range we didn't have before, but now we do. And the interquartile range, we talked about that also, the IQR. Okay, so that computes that information for us. This we haven't gotten to yet, so we'll hold off on that. Quantiles, okay, the estimate or the values here. What's your maximum score was 136. Then I have a page break here for the output. SAS output page 3. Then that continues and lists out, so we can see the max, the min, and we can see the third quartile, the median, and the first quartile. If you look at this and you have a data error, and so that, again, suppose we had a typographical error where we ended up typing in a 4-digit number, then that would see that my maximum score, so it gives me my my 5 highest scores here, and so it tells me what my maximum score is. Well, if it's something that's beyond the range of the data, it's going to tell me where that happened, what was the observation number. So that's another way. If you have a very large data set, you can say, well, it's your 517th observation. All right. If you had a very large data set, then you would know where to go back and find it and fix it. Okay. Also, it gives you the lowest in the event you don't hit enough digits. Or if you know you have, in this case we wouldn't, but if you know you have a negative observation, but your lowest observation isn't negative, you've forgotten the sign or somehow missed it. Okay. So those are just a few things you can do. If you don't put in the right data, you can't possibly get the right statistics back. Okay. So that makes all the things we marked up above, the sample size, the sample mean and variance, and all those calculations then aren't correct then for this data table. All right. The other part we have then is plot and plot size. Listing output is not known for its being pretty. All right. This is the first. Proc univariate is one of the few that does a stem and leaf display here. There is no legend on this, and so here the stems digit is 1, and the leaf digit then is just a 0 is counting the bar, so you're just multiplying everything by 1. So it looks like what you have here is 136 with 4. Now we can see, maybe, notice it's going by 2s here. All right, so whenever I look at this, I actually don't know if I've got 108 or 109. All right, it's lumped. It's got those two things together here by the way the stems digits are arranged. Okay. But we can see the 4-4. Remember, we had a mode, it's trimodal, and we have a 128 here, and our 6 observations here. Well, that's because it's combining together what 120. Is it 128, 129, or we have to figure out it'd be 127, I think. What was our minimum? Our lowest value was a 109. So it's going 108, 109. Okay, so this would be 128, 129. This is a box plot. Not pretty. What I use this for, though, is another key for the shape of the distribution, and it helps me identify if I've got a typographical error that resulted in something that was much too large or much too small. And so when I see a great separation between 1 or 2 observations and the rest of the data, I always go back and check that and make sure I got those things put in correctly. Normal probability plot is this. We can do a check, and we'll talk about this in the coming procedures. Testing methods we're getting into, not a SAS procedure. That our data are represented by the asterisk, and then there's a band of plus signs that's kind of a reference band, and if your data coincide with that, that indicates that you have data that are normally distributed, and the more the data points fall off of that reference band is an indication that you have a departure from normality. Okay, that's all the result of plot. I said the pictures aren't very attractive. Plot size is the only thing you have to control how big they are, so the default images for plot were horrible. They were compressed and only took us just a few lines, so I stretched it out to 25. We'll make pretty pictures in just a little bit. All right. So I don't. So putting these two here, only if you need the listing output and need things to be. You're just going to take a quick look and use it as a diagnostic tool. For the things we've done so far, We can look at proc means also. It also generates some summary information. Does not generate as much information as proc univariate does. And so proc means specify your data table, and then on which variable do you want this information. So for proc means, that output appears then beginning on SAS output page 5, because proc univariate took 2 pages. All right. By default, this is the first means procedure on page 5. You get sample size, y bar, so what we're calling n, y bar, standard deviation, lowercase s, minimum and maximum. That's the default information you'll get from proc means. All right, much less information than proc univariate does. Now, after you specify the data set, you can request other things. Pardon me, I'm off screen. After you request which data table you're operating on in the means procedure, you can request other statistics to be printed there. And so as soon as you make your first request, you need to make them all. So it's not going to be this in addition to the default. It's this. These are the ones I want. All right? So mean, standard deviation, sample size, standard error, coefficient of variation, and the range for the passenger variable. And that's on SAS output page 6, which is on the bottom part of that sheet. Widen my shot just a little bit. All right, so I get the mean, standard deviation, sample size, standard error, CV, and the range. I got those statistics in the order I requested them. So I can use SAS to kind of help build a table if I wanted to. So the other things we didn't have was S sub y bar here, coefficient of variation. We didn't have a symbol for range. Range is range, right? You can get high-resolution graphics in SAS. One of the procedures is proc G chart. G stands for graphics. And so you want a vertical bar chart for passenger. All right. And we want type equals %. That is, we want the bar heights to be what? The % of the sample. And so I get these kinds of images. You can recover these from SAS as JPEG files, bitmap, whatever graphics file. Whatever graphics format you like for file types. There are some things you can do to change where the midpoints occur, and I didn't get into that. This last part, this was just a little manipulation I did. I wanted to create a group equals passengers and run a box plot for passenger. This is vertical by horizontal, and that was in order to generate this box plot given here. If I would have had multiple groups across here, I'd have side-by-side box plots. So that's a prettier picture. We can do all kinds of stuff here. Okay, these last two images occur in a graphics window. They are not in the listing output window of SAS, and so that you can take these two images and move to that graphics window. You can right-click on the image, and you can either export it, meaning save it as a file, or you can copy it and paste it into a document as I've done here. Sometimes saving it as an image first and inserting the image in your document or PowerPoint presentation is better. Cut and paste depends on the machine. Sometimes I see the titles and some of the fonts get a little bit corrupted when I do a cut and paste. So usually if you save the image and then insert it, then that's usually a little bit better. The other form of the output we can get is an HTML. If you are using virtual SAS, this is what you have to put this control on your HTML. All right, because otherwise all these files that it generates are going to land on the virtual server, and it can shut the virtual server down. Okay? So what we change here, and I don't think I did it on the other program. Let me look real quick. I do not. What we're changing then is we're at the top, we're looking at the closing the listing. What's different in the tops of these two programs? This display manager, log clear, output clear. The output, this refers to the listing output. Things accumulate there unless we clear it. The option statement applies to the listing output only here. So that's why it's not over here. The log window, things still accumulate, as in that Getting Started in SAS handout demonstrates. Okay, so I can still clear the log window. If I put the output clear, it's not wrong. It's just not necessary. All right, so whatever you have in the quotation marks here can be your choice. If you're working on a standalone installation of SAS, you could divert these to a USB storage device, whatever drive it's in. Okay, or you could divert it to your C drive. But on virtual SAS, you have to divert it to H. Okay. This one here, you can change this name down here. This is the file name it's going to be in these directories you've created. You have to create this My SAS Files folder before running this command in SAS, because if you haven't created it, it says this folder doesn't exist or this destination doesn't exist. So it doesn't create it automatically. It'll create this second one, the subfolder, but it won't create the My SAS Files. All right, and then you can give it a specific name. So then the next program you run, you may want the same path and the same G path, but then you choose a different file name so it doesn't overwrite the previous result. Turn the graphics on. So this automatically, given these options here, this is enabling the HTML output and telling it where to go. Then also enable the graphics. Okay, in this last release of SAS, there's a lot of procedures that have some automatic graphics, or they have some graphics you can request, and they look really nice. So the very first part here, the data 1 input passenger data lines, is just as it was before. So is the proc print. What's different about the procedures here is histogram. This is an HTML statement only. You can put it, but it won't do anything in your listing output. So it'll run, but it just won't generate anything over there. It's going to generate a histogram in part of the univariate output. So going back then to the SAS output, the thing with the HTML output is you don't see page numbers. All right. And so this is the result of the print procedure. Whoops, that one's not labeled. Well, I keep wanting to write the R's first. Proc print, and so we saw this before. So this is this entire page, and it's using a larger font, and it's using a table like we see formatted for use on the web. Okay, so that was the print procedure. Proc univariate. We see again labeled at the top. Most procedures will write what the name of the procedure is at the top. And we see those same tables of information that we saw in the listing output. They're just in HTML formatted tables now. Okay. I was able to get all the quantiles information fixed into one page here. We're still skipping over this part. So like I say, the information we're given is no different. The content of those tables stays the same. It's just the appearance. Here I just used the plot option. The plot size I didn't use, but this plot option in HTML is just dreadful. I don't recommend it. I'll show you why. Because that's it. Blech. All right, the plot option down here. So it recognized that in ODS listing that was really a table, so it's trying to put it in a tabular arrangement instead of a graphics file. So that's why it looks so horrible. Same with the normal probability plot. It took a text file and is trying to put it formatted as a table. Just a bad idea. All right. This is the histogram that it draws. There are some options on the histogram. We can change colors. We can change midpoints and such. So I just gave you the basics. So this is that histogram statement that we added right here. Okay. Proc means, same as I had on the previous ODS listing enabled. And so we get these two tables then for the two different means procedures. Okay. You can then, when you get these, you can copy this whole, all this information into Word or whatever you're using. You can grab the whole table and change fonts and do whatever editing you want then. G-chart looks, the code is exactly the same as was before. We end up with this image and it's embedded in the HTML file. And then lastly, the box plot looks a little better, I think, than it did in the graphics window. So when it came to HTML, it got a little bigger, a little easier to read.